Okay, so this next one, number 9, you can tell it is a circle because the x is squared and the y is squared, right? So you're going to have a circle, which means it's not a function. It does not pass the vertical line test. So you can't put it in your calculator. But it works like the transformations for a parabola. Like this is a parabola right here, right? And it's going down, right? So erase this. So I've got a circle. Okay, a circle here, check. And then this is a upside down parabola, which could look like that, or it could go 4 times. We'll see. And then these would be the intersections are the solutions. Okay, solutions are intersections. So this is a transformation, so that moves it from 0, 0, right? Normally, a circle would be x squared plus y squared, right? And then that would have a center at 0, 0. So, but this is going to be to the right 3. So I'm going to go 1, 2, 3 to the right. And then this is going to move it up 3. It's opposite. Okay, so that the center for this one would actually be positive 3, positive 3. All right? It's kind of the value that would make these equal to 0, sort of like zeros. So here is the center of that circle. All right, and then this is r squared, right? So I'm going to take the square root of 9, which is 3, right? So the radius is 3. So I'm going to go 1, 2, 3 to the right, 1, 2, 3 up, 1, 2, 3 to the left, 1, 2, 3 down. And then I'll just kind of connect those as best I can. And that is my circle. Okay? All right. Now I've got, so that's that, right? So the radius there is 3. And the center of this would be positive 3, positive 3. Now for the parabola, right, because this is squared, only the x is squared, all right? Y is not squared. So that's going to be a parabola. And it's going down because A is negative. All right, and that means I can just put that into my calculator. All right, so I go y equals, I go y equals, and I've got a negative 2, and then x minus 3, and then that is squared. Okay, that's vertex form, so I can see that the vertex, this was a shift to the right 3, 1, 2, 3, and then I know it's going down, and instead of down, over and down 1, it's going to go over and down 2. All right, and then over and down 1, 2, 3, 4, 5, 6. Okay, so over and over 1. So the vertex here would be at positive 3 and 0 because there's nothing out here. All right. And I go over 1 and down 2, over 1, oops, then over 1 and down 6. And I'll connect these as best I can. All right, and if I look at the table, I'll see those points. They have to be exactly the same. All right, so I'll go second graph, look at the table. The vertex was at 3, 0, so let me find where x equals 3. And you can see how it's symmetrical, right? 2, 2, negative, negative, right? And so my vertex is right here in the middle at 3, 0. Right, and if I look at the graph, I'll see my vertex there at 3, 0. That kind of helps you too, if you find it. All right, so 3, 0 is the vertex, and then I've got 2, negative 2. All right, so go over here, 2, negative 2, that's that point. And then the other one is 4, negative 2. So 1, 2, 3, 4, and negative 2. There's that point. And then I've got 5, negative 8. So I'll go over 1, 2, 3, 4, 5, and then down 8. And then I have 1, negative 8. So I'll go over 1 and then down 8, and there's this guy. All right. So this point right here, the vertex actually is the point that they both have in common. That is the solution. They only have one point in common. You have their circle here, and then it's like tangent right there. Okay? So the one solution is right there, the point that they both have. And if I substitute in, all right, 3 and 0. All right, the solution is 3, 0. If I substitute in, that's a 3 here. 3 minus 3 is 0. And then 2 times 0, I get y equals 0. Okay, so that checks out. And then this has to make this true, too. So if x is 3, all right, that would be 0 squared. And then this is, if y is 0, right, if y is